Okay, let's try another subnetting example. In this case, we won't have PCs as hosts. The hosts off of these remote routers, for instance, the hosts off of router 4 here, for instance, these hosts would be maybe using their own subnetting scheme. Perhaps they're using a private address range or something else, so we're not going to worry about the hosts. What your problem is you've been given the task of subnetting a design for the serial links between the routers. These links here, 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 and so forth. Each of these represents an individual network. And remote 1, we'll call it network 1. We'll say that has network 1 and so forth and so on. 2 for remote 2, network 3 goes to remote 4 off of main, and so forth and so on, all the way around to 57 networks. And router interfaces are like a host interface. Just like a PC, a router has an interface, so it counts as a host address, you might say. And in this case, if you notice, there are two interfaces per serial link, and therefore there are two hosts per network. So there are two hosts on every network, and there are 57 networks. So let's ask our same basic questions that we always ask, and that is, how many networks do I need? And in this case, we need 57 networks. Well, we know that we have 8 bits to work with, because we have over up here at the top of the screen 192.168.5.0 corresponds over here to the subnet mask, meaning the 0 means that's host bits, and we can use host bits for our subnetting. So we have 8 bits to work with. If we borrow 1 bit, we would end up with 0 usable hosts. 2 bits would get 2 hosts. 3 bits would give us 6. 4 bits would give us 14 hosts. And the previous example, 5 bits gave you 30 hosts. Well, in this case, we would have to borrow all the way to 6 bits, because 30 networks would not be enough. So we have 57 networks. We'll have to borrow 6 bits. So let's go take a look at this. And we knew that the subnet mask here was 255.255.255.0, and that was the network address we had started with. We know we have 8 bits here to manipulate in this case. Now, it's not always going to be 8 bits. So far, all the examples have been we just use the last octet of a class C. There'll be examples where we don't have 8 bits to manipulate. There's a lesser number or a greater number, and we'll show you these examples as time permits. Now, in this case, though, we're going to borrow 1, 2, 3, 4, 5, 6 bits, because 6 bits to the 6 is 64, minus 2 is 62, and 57 networks would require that many bits. We'll have a few extra, but not too many extra. Okay, so we're borrowing 6 bits, and we want to know the first, I believe it was 3 network addresses, and the last network, and the host range on each of those networks. Now again, the first network is actually the 0 network, and for now we're going to consider this to be unusable. So the first usable address, we would use binary. We would count in binary to for these first 6 bits, acting like they're kind of by themselves for now. And then for the host bits, we would set it to 0 and say that 192.168.5.4 is our first network address. And again, because that's 1, 2, 4, 8, 16, 32, 64, 128. So .4 is our next network address. Our host address, first host address, would be 192.168.5.5. And of course the network address would still be the same. And the next host address would be 1.0, just simply counting up in binary. And notice the 1.0 form. Remember I told you the last host on any subnet takes the form all ones and the last bit being 0. Well, because there's only 2 bits here, 1, 0 is the last host on the range. And that makes sense because one of the other questions we need to ask when working the problems is how many bits are left for hosts after we take bits for subnets. In this case, there's only 2 bits left for hosts, these 2 here. If that's the case, 2 squared is 4 minus 2 is equal to 2. There's only 2 bits, only 2 hosts per subnet allowed. Is that a problem? Well, no, because the serial links, there's only 2 hosts, one router then the other router. So all we need is 2 hosts, so that's okay. And the broadcast address of that network is 0111, and therefore 192.168.5.7 is the broadcast address. Now that makes sense because what would be the next binary number? Well, these 3 bits are full here. So the next binary number would be 001000, just counting up in binary. And that would be 192.168.5.8. That is okay because the increment here is 4. And we are working off of bit 4 as the last bit that we use for subnetting. So that works fine. Alright, based on this information, let's go fill in some things on the router diagram. And we'll say that this interface would have been programmed as 192.168.5.5, and this one would have been 5.6. Alright, that's the first network. So we would ask about the first 3 networks and the 57th network and the host addresses on those networks. So this was the first network and its host addresses. That's been taken care of. So let's go back and look at the second and the third network. The second network we've already solved as far as the network address. It was 5.8. And the first host would simply go up 1 in binary to 5.9. And the second host, whoops, made a mistake here. Would simply be 5.10. The broadcast would be 5.11. And we don't need to worry about that because I really wasn't asked about that. And the next network would be 0, 0, 0, 0, and we have one room here left to go, 1, 1 in binary. And when we're determining the network addresses, we'll go ahead and set those bits to 0. And that gives us 5.12. And when we skipped 11, that would have been the broadcast address after 10 here. 5.12 would be the network address of the third network. This was the second network. This was the third network. So what would the hosts be this time? They would be .13 and 1, 0 would make .14. Okay. So 9, 10, and 13 and 14. This would be .9 and .10. And this one would be 13 and 14. Now what is our new subnet mask, by the way? Well, the first one was 255, 255, 255. That part's not going to change. Now the last octet, the first 6 bits are being used for networking. So if the first 6 bits are for networks, it takes the form 3, 4, 5, 6, and these last 2 bits are host bits. That's what the last octet of the subnet mask looks like up here on the top left. And that ends up being 252. So 252 is the last octet, and that is your new subnet mask, incidentally. Now that solves for the first 3 networks. How do we find the 57th network? Okay, let me clear up my screen here. Okay, there's two ways of solving for the 57th network. One way, like I said last time, is to build a false number line. The other way is to simply say, hey, we're incrementing on bit 4 here, right? And with the fourth, the bit position that's weighted as 4, and we're at the 57th network. So one way of doing that is to go 57 times 4, and you get 228. And then what you do is you would go to the number line here and make 228, in which case that would be 128 and 64 is 192. That's okay. 32 more would make 224, so let's put a 1 there. 16 would take us too high, and 8 would take us too high. 4 would make 224 plus 4 would be 228, and that would make the 57th network. And of course that's 192.168.5.228. The other way is to make a false number line. If you notice, if we'll take this part and pretend like it's its own number line, let's start there with 1, 2, 4, 8, 16, 32, and let's add up for 57. And that would be 32 plus 16 is 48, plus 8 is 56, and that 1 makes 57. You could have gone about it that way too. So if I ask you to find some higher number network that you where it's tough to figure it out, just in your head, that's how you would do it. Either multiply the number of networks, if I'm after the 30th network, you'd multiply 30 times the increment here, which in this case is 4, or you would draw a false number line for your network bits and add up the bit sequence to get the network in question, in this case 57. So those are your two methods. Now that's the network address. What is the host address? First host is 01 here, so that would be 192.168.5.229. And your second host would be 192.168.5.230. 231 would be your broadcast address, and 232 would be the next network address, which would be plus 4 from 228. That makes sense. So what you would do over here on the router diagram is this one would have been 229, and this one would be 230. Now, I didn't say that the first network address would have to go to the main. I've just been doing that on a consistent basis, but for just consistency's sake, for this problem, let's say we'll put the first address on main, we'll put the second address on remote, so 229 and 230 would be the host addresses on that 57th network.